Now, had we regarded the force on the 200 gram mass as F1, with F1 being positive, we would have concluded that the 200 gram mass had a change in velocity of plus 6 meters per second. In the first, a change in velocity of negative 12 meters per second. So that the after collision velocity of the first would have been 4 meters per second minus 12 meters per second, or 8 meters per second, and that should be negative 8 meters per second. And the velocity of the second after collision would have been the negative 3 meters per second, and the change in its velocity would have been plus 6 meters per second, and that would have been plus 3, and that would have been 3 meters per second. Okay, we would still find that the total kinetic energy after collision is greater than that before. Okay, because the speed of V2 is the same as it was before, so it's going to have the same kinetic energy. Doesn't matter whether it's the before kinetic energy, negative 3 meters per second, or the after kinetic energy, plus 3 meters per second, because the velocity gets, or the speed actually gets squared. Okay. The first object is moving faster than it was before collision. It started at 4 meters per second. It ends up with a speed of 8 meters per second. Now, the velocity is negative 8 meters per second, but of course that gets squared. So the square of this is bigger than the square of this. You still end up with too much kinetic energy, but you have a different interpretation depending essentially on the way these objects interact. Okay, so this is another valid interpretation of the same question.